Hi, statistics family. I've tried making this video a couple times, and every time that I go back and read the material again, I realize I've made a mistake. I didn't post the second video. I'm glad I didn't because I would have screwed you up a little bit. So I have reviewed the material again. I'm gonna hopefully third time's a charm for this. So hang in there. I know we are past the due date now, but there's always time to resubmit. Um, or there's time if you haven't submitted already, you still have time. If you've already submitted, wait till you get feedback. They'll tell you exactly what's wrong, and they'll show you how to correct it. But if you have not turned it in yet, or if you just want to watch, this is kind of for you. So I'm going to share my screen. In the first video I did, I shared my screen, but I didn't share, then unshare, then share, then unshare. So you only saw one screen the entire time when I tried to show you multiple. So hopefully this works this time. I'm going to share my screen. We are working on, this is week 2 case study. So let's look. So this module, we talked about the one sample Z test. I'm going to make this go up a little bit or blow this up a little bit because I noticed that was a problem too in one of my videos, and I'll try to upload this to YouTube so maybe the quality is a little bit better. Um, but this is the case study description, and the population that we're using is this right here, the world unemployment rates between 1991 and 2023. Sorry. So that is our population. It tells you a little bit more down here, but they gave it to us right in the case study description. Um, your variable of interest, we had 3 options. Our options were the overall unemployment rate of 2023, the female unemployment rate of 2023, or the male unemployment rate for 2023. No other years. These were the only ones they wanted us to focus on. So I chose the overall unemployment rate for 2023. You can choose whatever you feel like. Everybody's going to be a little bit different. So this is also going to be different for everybody. So I live in Lake County, California. So my rate is going to most likely be different than your rate. You want to look at, if you're in the US, you can look at the census. If you're in a different country, you can use whatever is available to you. I went onto a government website here in California. That's where I got my information. My unemployment rate for my location is 6.6. So then we have to make a type of comparison. They're wondering, we have to create a research question, and we're looking for an equation of some sort that will be different than, greater than, or less than. And it shows you down here is the mean variable of interest, type of comparison, unemployment rate for your location. So our variable of interest, like I said, there was only one, and mine is the overall world unemployment rate of 2023. I didn't rate it right here. And I thought that maybe it would be less than the unemployment rate of Lake County, California, my area. So we'll see. So first we have to collect the data. So in our data set that we were given, the rows of data start at 3 and end at 268. That is where I get these numbers. I didn't just create them on my own. And we need to pick a sample size between 30 and 40. I chose 30. 30 is sufficient. It is smaller, so I went with it. Do what you feel is necessary, though. You can definitely do anything from in between 35, 40, it's fine. And so we got to randomly select our sample, which means that we have to come up with a way that is unbiased to select our numbers. So you can use, they give you an option, a website like a research randomizer, or you can use the rand between function in Excel. And I'm going to show you how to do that in Excel. And I'm also going to show you what the problems are in doing that, because there are some problems. Okay, we're going to share this screen now. Okay, so this is my data set. This is all the data info right here. These are the numbers that were randomly selected through a randomizer. So the formula is in here. This is what it is. It is equals rand between, and this is the lower limit, the bottom 3, and the upper limit, 268. And in Excel terms, the syntax, this simply means we want to find a random number between 3 and 268. That's all that matters. So you press enter and it gives you a random number. The first video I did, I showed you a very tedious way of doing it. There's an easier way, and I'm going to show you. So you're going to drag this down by however many you need. So mine was 30. So I'm going to go to 33 because that is where everything ends. So here's the problem with this function, and I'm going to work on a formula to fix this. But this does not, as random as it is, it does not mean that there aren't duplicates. You see right here, 74, 74, or 174. And I think there could be more in there that are duplicates. So when it comes to that number, you just have to pick another number. You can pick one nearby, you can randomly select another one. It doesn't matter, but you do have to work for duplicates because that won't work for our data set. And then in other areas, such as, let's do this one, there's no data here. None. And that does not mean the data equals 0. It just means the data is not provided. So putting 0 there would be inaccurate because we don't actually know if it's 0 or not, and it's probably not, so 0 is inappropriate. So once again, you're going to want to find a different number where data is provided, right? I was helping somebody with their project earlier, and they chose the female overall unemployment rate. And as you can see, there's not a lot of data for a lot of countries for female unemployment rate. And we can talk about that at the end, what kind of action we can do about that. If that's what if female is what you decided to go with, there's I'll give you some helpful hints at the end. But you definitely, for instances like these, you have to pick a different number, or otherwise your study will not be accurate. So here is my data, right? So I'm going to go back to the case study so you can see what we're doing next. Let's see. Okay, so we found our rand between. We got all of our data. So now we copy and paste. So I'm going to show you how to do that. I was tutoring another lady earlier, and she was really struggling with this. So I'm going to show you a little bit. So when you copy and paste, there's another way to do it than just right click. There's another way to do it other than this method. There's another way. You can do this and press the CTRL button or command button, depending if you have a Mac or just a regular PC, but I have a Dell, a PC, so mine is Control and then C. If you have a Mac, it's Command C. So that is how we copy that. And then once again, if you want to paste it, mine's already pasted, so I'm not going to do it again. Then you do Control V. It will not be Control P for paste because Control P is actually print. So it is Control V instead. So we're going to go back and look at my data. All right. So as you can see, there were many little boxes and they didn't paste properly for me. So I just deleted what I could and it's just in one big window. I don't think it matters that much. If it bothers you, you can fix it on your end. It didn't really bother me. And I don't know if it's really significant. I could lose points on that. I could not. It's up to you. Okay, so describe the data. So for this um for this case study, we are given a sigma value or the standard deviation. So it's different for each one. Since mine is the overall unemployment rate of 2023, mine is 5.044%. If you have one of the others, these are the ones you choose from. So that's what I put here. A, 5.044. And so this data, you're going to have to take and paste into your toolbox. And these are, I'm going to show you how to get some of these. So they want your sample mean, your sample standard deviation, your minimum, all your quartiles. And then it also wants you to paste these graphs. So we're going to do that. Stop sharing here. Okay. So here's my toolkit. Share. Here's my toolkit. So because I've already done this, all of my data is over here. Remember that if you have 30, then like it starts at 2, so you're going to want to go down to 32. So this is where you put, remember what I said in the last video, that was not about this one. The only boxes we change in our toolkit is are the yellow boxes. Everything else is automatically calculated for us. It's pretty nifty. So this is where we put our sigma, our known sigma. And then this is what I got wrong in the other video, and this is what I'm fixing. So it gave us our sample mean. This is our sample mean. And this is the X bar. This is the sample standard deviation. So in the first video, I just put this again. I was wrong. I'm going to lose points on that. I can't go back and fix it again. So I'm going to lose points on it. But hopefully if you see this video, you won't. So it's not 5.044 like I said originally. It is 6.620 because we round to the third decimal. Okay. So when it comes to the box plot in histogram, it wants you to copy and paste. This is how you do it. You select on the outer border. So not here. You don't select here because that will not give you what you want. You want the whole thing. And once again, you Control C. See if it'll do it. You Control C, Control V. Then you come back, Control C, and Control V. I'm gonna stop because there's something else I want to show you when it comes to the box plot. So I'm also going to lose points for this, I think. So I'm just letting you guys know when you do paste those. I don't think if you can see it. This is the title, the overall unemployment rate of 2023. I changed it down here too. That is what it's supposed to look like. My original did not. Oh, almost forgot the quartiles. So you want the quartiles, which is the box plot. So let's go back. Okay. Okay. So this part right here, those are your quartiles. We're going to read them on these are your quartiles. So remember, this is the sample mean, This is the sample deviation or the sample standard deviation. This is the sigma that was given to us. We don't need to know about this. Oh, see, I added one more extra person. Sample 31. Don't make that mistake. It'll count for you. Okay, but so let's read this box plot because I know I struggled with this the first week. So hopefully I can show you how to do it. Okay, so this line right here at the very bottom, that's your minimum. All the way up to this first line, the outer edge of the box, that is your first quartile. And I know it's going to seem kind of weird, but this line right here that goes through the middle, and it can kind of be in the middle no matter where it is in the box, that is actually your median. And this line to the outer edge of the box, the top edge, that is your third quartile. And this line up here, that is your max. It is confusing to read these, but that is how you read them. That's what really helped me. Hopefully it helps you. So let's go back. Okay, so we did that. So based on your descriptive statistics above, what do you think the answer to your research question will be? Just take an eyeball. For me, the standard, the rate for me was 6.6, right? And so according to this box plot, the second quartile, the median, is pretty close to my unemployment rate. So I think based on the statistics above, that the unemployment rate will probably not be less than my area. The histogram and box plot show that 6.6 unemployment rate of my area is near the lower end of the median, which means that approximately like 50% of the likelihood of it not being, it's going to be likely that it will be greater than it will be less. So this is the make inference, and this is kind of hard, so we'll go over this. So it wants you to explain why this test is appropriate for the case study. And it tells you right here, include the type of data, quantitative or categorical, the number of variables, the number of samples, and whether or not sigma is known. So the data, the best way to tell if the data is quantitative or categorical is quantitative can be measured. So it could be how many sick days did somebody take? Could it be how many babies were born in a hospital over a certain year? And categorical is like barcodes. Categorical is like favorite music genre, who likes horror movies versus comedy, that kind of thing. Um, it is not measurable. Um, so the number of variables, this is the one sample Z test, which means there's only really one variable that we're using, and we were told to only choose one variable, so it's one variable. The number of samples between 30 and 40 is sufficient, and we chose 30, or I chose 30. And whether or not sigma is known, sigma is given to us, so yes, it is known. So for all of those reasons, it is appropriate to use this test. Okay, so there's requirements. So we can, so we can use the one sample Z. It wants to know a simple random sample was drawn from the population. It's random. A sample is random if the way it's selected, every single sample, like data value, had an equal chance of being selected. So it's not biased. It's simply a luck of the draw. And we use the ran between function, or at least I did. So it's unbiased. Like I didn't choose anything. The computer chose it for me. X bar is normally distributed. I can't talk, guys. I'm so sorry. So the sample size is 30. which is sufficient. It's considered large. And anything that is large, like 30 and above, is considered normally distributed because of the central limit theorem. This guy right here. This is what tells us if it's normally distributed. And it is. Unless it's small and then it tells us that it is, we can assume that if it's large, it will be. And the sigma is known. And so I posted it again. So now we have our null and our alternative hypotheses. So it just tells you here that the mean of, I put it down here, the world overall unemployment rate of the year 2023 is equal to the unemployment rate of Lake County, California, which is 6.6. The null hypothesis will always be equal to. That was on the quiz. And when we go back to the toolkit, I'll show you what it looks like. And the alternative is that the mean overall unemployment rate of the year 2023 is less than the unemployment rate of Lake County, California, which is 6.6. And so we have to choose the level of significance, which is noted by the Greek letter alpha, that we will use for our hypothesis test. And the significance levels that we use are either 0.01, 0.05, or 0.10. 0.05 is simply the most common, so we're using that. And you don't put the alpha value anywhere in the toolkit or toolbox. It does not go anywhere. This is just simply a number that you pick and then you compare it to another number. You can compare it to the p-value. So this was my test statistic. This was my p-value. I'm going to share the toolkit so you can see what it looks like on there. Oh, I changed that. Oopsies. Okay. So if you remember on the quiz, there was one question where it just asked you to write the HO and the HA. And like, how would you write it as an equation? So the null hypothesis, the first one, HO, it's always going to be equal to. It's only the HA where the sign changes. So if you look at your toolkit, this isn't yellow, so you're not supposed to change it. This is yellow, so you are supposed to change them. So the null hypothesis for me is that the mean, this is the mean overall unemployment rate of the world of 2023. This is what that means. The mu, I think that's how you pronounce it, is equal to 6.6, which is the rate of my area. And the alternative hypothesis is that the mean is actually less than 6.6. So these two values are automatically calculated because of the sign and this number. So the test statistic is this one, and the p-value is this one. But I'm going to change this real quick. So if it was different, because those are your other options, if it's different, then this is your p-value. The test statistic doesn't change. And if it is changed again, the p-value changes again. And I know some people were concerned that their p-value was 0. And a lot of people have been getting that. And I don't think that's incorrect. Because if it was, then the data would, I mean, it's automatically calculated. So as long as you're inputting the data correctly, you should be fine. If it says 0, then that's probably what it is. So this is our test statistic. So we give them that number and remember this number. So mine is almost 1. It's 0.989 in this case, as we round up. And for those who don't real know why we round up, it's because anything that is 5 or above, we round up. And if it's 4 and below, it just stays the same. So I didn't fully change it. But now we have to make a a statement about rejecting or failing to reject the null hypothesis. So I'm going to stop sharing and go to another one because I have this one up too. Okay, this is directly from our textbook. So if your p-value is less than alpha, then we reject the null hypothesis because there is sufficient evidence to conclude that the alternative hypothesis is true. That just means we're saying no, it does not equal that number. There's a lot of evidence that shows that the other equation that we made is likely true. And if the p-value is greater than alpha, then we fail to reject the null hypothesis because there is insufficient evidence to conclude that the alternative hypothesis is true, which just means that, okay, we can't prove, it doesn't look like we can prove that the other hypothesis is true. So the first one, there's a chance that it's correct. It's not a for sure thing, but there's a higher chance that the null hypothesis is correct. And so come back. Okay, so since my p-value, does that move? Yeah, okay. Since the p-value of 0.989, technically I didn't round up, is much higher than the 0.05, we fail to reject the null hypothesis. And because we fail to reject the null hypothesis, we conclude there is insufficient evidence that the alternative hypothesis is true. So we can say that based on the p level, and we saw this in the box plot, the majority of the data value sets were in the second median, which is where mine was, or my Lake County data set was. So we can't really prove that it is less than 6.6, but it could actually equal 6.6, which is why we fail to reject, or we're more likely to accept that the null hypothesis is true, and we can reject the alternative hypothesis because we're fairly confident it's not true. Okay. So now we have to do a confidence level for our confidence interval, and you can choose 90, 95, or 99. I think it's 95% is the most common. My toolkit was already on 99%, so I just went with that. Yours can be different. And so we go back. This was my lower bound. This is my upper bound. And when we find it, I'll show you in the toolkit, we can say that it shows you how to say it, we are 99% confident that the true mean of the world overall unemployment rate of 2023, the variable of interest, is in the interval from the lower bound, which is 6.333, and to 11.000. So I'm going to show you on your toolkit where you can find those values. And it's right down here. So see, this one's at 95%, so that's not going to work. We have to put it 99. And see how that changes it? So there's my margin of error. And here's my lower bound. And here is my upper bound. And so the true mean is somewhere between those data points. And so compare the confidence interval to the null hypothesis to determine if we really should reject or fail to reject the null hypothesis. And seeing as my local unemployment rate is 6.6, and the interval is from 6.3 to 11, there is a chance that the true mean is in fact equal to 6.6. There is a chance that it is. So we fail to reject the null hypothesis because it could actually be true. You're not rejecting it. Okay, so this is the part where you kind of have to get creative because yours is going to look different from mine. Everybody has their own opinion. Hey, Carter. Sorry, my dog's eating something. Um, so the for me, it was the unemployment rate is likely lower than the world overall unemployment rate, but it still falls in the confidence interval, which means that our location is somewhat similar to the rest of the world. And I said follow-up studies should be planned to monitor the rate. A growing rate could indicate a failing economy, or we might need more job opportunities in educational programs. Who knows? I was talking to another woman earlier. We were studying and I was helping her through this. And she chose the female unemployment rate. And this is kind of where, sorry, my dogs. This is kind of where the whole missing data thing kind of comes in handy for that one. So I'm gonna stop sharing that. And I've worked in the field of having to track hard data like this before, guys. So I'll give you some perspective. So we could say, you know, when you take your sample and it is the overall female rate is this, and most of it is actually empty, then the values that we do calculate with, those are technically skewed. That's not an accurate representation of the female unemployment rate because we simply do not have the data. And that if you're going to use that, I think it would be helpful if you pointed that out. I used to work for a child who I had to record how many times he screamed in a day. And I'm telling you, he screamed about 500 times a day in a 5-hour period. This is something that I had to track one by one by one. So him, a scream was defined as a vocalization of a louder decibel and a high pitch of a minimum of 3 seconds with an offset, which means it stopped for a total of 10 seconds. That's one scream. It has to last 3 seconds, and in order for it to be stopped, it has to have not happened for 10 seconds. So if he screams twice, then you have to assume that there's 10 seconds in between both of those screams. So if you, but there were times where he screamed for 30 minutes at a time with no 10-second break in between. So the data was skewed. If the data would say, oh, he didn't scream 500 times a day, he actually screamed 100 times. And that's where the data taker, had to put in the notes, yes, it's lower because he never stopped screaming. The data is not accurate. So if you're using the female unemployment rate data, that is something to consider. Is your data is wildly inaccurate, and it's very, very skewed. Even if it is normally distributed because it's a larger sample, it is still not accurate. That's just my 2 cents as somebody who's had to work in the field before and somebody who's had to deal with that before. So if you are doing the female rate and you do decide to do that, you could say something like, we need equal representation in the data so we can, Carter, Stop. So we can have better representation of women in the workforce or something like that. It could be anything. But that's all I got for you today. I'm gonna upload this to YouTube, Carter, and I'm gonna get my dog to stop chewing shoes. Okay, have a great day, guys.